Hi everyone, for this question, find the volume generated when the region bounded by the given curve and line are rotated completely about the given axis. So we have a quadratic graph and a linear graph. So first we draw out the graph to identify the region. So for quadratic graph, y equals to x squared, concave outward, intersection at origin. Meanwhile, for this linear, y equals to mx plus c, gradient positive going up, and then plus 2 is the intersection here. So the region bounded by these two curves, and we're going to rotate about x-axis, so we're going to see it vertically. This region going to rotate to generate a solid here. So we have two curve concept here. As you can see, this region is enclosed by two curves and it doesn't attach fully to the x-axis. So for two curve concept, volume formula will be y1 square minus y2 square and integrate respect to x. So y1 will be referring to the curve above and y2 will be referring to the curve below. So first of all, we need to find out what is the upper limit and lower limit. To find that, we need our intersection point. To find intersection point, we need simultaneous equation where y equals to x2, equation 1, y equals to x plus 2, equation 2. When we substitute, we form a quadratic. As we solve here, we have x equals to negative 1 and x equals to 2. So lower limit start from negative 1, upper limit go until 2. Then we put in into the formula here where volume equals to pi, lower limit negative 1, upper limit 2. Then the curve above of this region will be linear. So it will be x plus 2 square minus the curve below, it will be quadratic square and integrate respect to x. We simplify first. As x square and square, we can get x power of 4. Then we can start integrate. So a bracket of x here, power plus 1 over new power, and the coefficient of x, a, which is 1. Then this one power plus 1 over new power, upper limit 2, lower limit negative 1. Then we substitute upper limit minus lower limit. Then we can evaluate using calculator to find out the value here. So volume in unit cube.